We're now going to analyze the inverse tangent function. Recall, based on the graph of y equals tangent of x, that the tangent function is not 1-to-1. So what we need to do is restrict the domain of y equals tangent of x to make it 1-to-1. A logical restriction is to restrict the values of x to be between negative pi over 2 and pi over 2, but not inclusive, of course, because negative pi over 2 and pi over 2 are undefined values for the tangent function. So, bearing in mind that if we have y equals tangent of x, our domain is going to be negative pi over 2 to pi over 2, and the range is all real numbers. Therefore, the domain of the inverse tangent function is all real numbers, and its range will be negative pi over 2 to pi over 2. In addition, we have to analyze the composite functions for the tangent function. We have f inverse of f of x equals the arctangent of the tangent of x equals x, where x is going to be between negative pi over 2 and pi over 2, the restricted domain of the tangent of x, and f of f inverse of x will equal the tangent of the arctangent of x will equal x. Here, the domain of the arctangent of x is all real numbers, so x can be any real number. So here we have the characteristics of the arctangent function. The domain of y equals the arctangent of x is the range of y equals tangent of x. That is, the domain is all real numbers. The range of the arctangent is negative pi over 2 to pi over 2. Finally, let's look at the graphs. In red, I have the graph of y equals tangent of x. To obtain the graph of y equals the arctangent of x, we reflect the graph of y equals tangent of x about the line y equals x. Finally, we notice that x equals negative pi over 2 and x equals pi over 2 are the vertical asymptotes of the graph of y equals tangent of x. So y equals negative pi over 2 and y equals pi over 2 are horizontal tangents in the graph of y equals arctangent of x. With all this information, we can now go ahead and analyze or evaluate an arctangent function. So, suppose we want to know the inverse tangent of 1. We're looking for an angle theta that equals the arctangent of 1. In other words, the tangent of what angle gives me 1. Remember, the angle must be between negative pi over 2 and pi over 2. That domain restriction was required in order for the tangent function to be 1-to-1. So, the tangent of what angle is 1, where the angle is between negative pi over 2 and pi over 2? It turns out that the angle theta is going to be pi over 4, because the tangent of pi over 4 is 1. Therefore, the inverse tangent of 1 equals pi over 4.